What do you mean by Boolean logic? Raise your hand, don't answer it. What do you mean by Boolean logic?
Gates that help make for the
I haven't asked for the gate. It's the Boolean logic. I haven't said Boolean logic gates. Just the Boolean logic. What is it? Ali? True or false? True or false? Condition. Which conditions? True and false, zeros and ones, yes or no. Okay. So what we have Boolean logic is basically binary, zeros and ones, and so forth. In this chapter, we will go through all these parts. So we start with the role of logic gates. All of them. We're going to do all different logic gates. Now, why are we using logic gates? Why? What's the importance of it? What's the importance? Why do we use them?
safe for computers because everything else is logic.
Everything we have electronics, everything, even this one, they use logic gates. One of these, you will see that, especially if you're doing electronics engineering, electrical or computer system, you will see this one. It's the foundation of electronics. If you do, yes, if you do it, it's the foundation. It's the foundation of electronics. So what we have explained the role of logic gates in computing. So we will go through all these logic gates, what they are, their symbols, their truth tables. We will discuss that and where do we use them in real life. Okay. So we are going to see the truth tables for all of them and understand the real life implementation. First one, as we said, what are logic gates? Can you give me a bit more clear definition or explanation? What are logic gates? Logic gates flow the control of electricity in the circuitry. Okay, all the circuits where the data is sent, or zeros and ones, they control the flow of electricity in binary state, zeros and ones. The new one which our researchers are working on, what do we call them? So this is quantum computing. Quantum computing. They are. This is like Boolean, yes, zeros and ones. Currently, the computers or all these systems we have, they only use zeros and ones, two states. But the quantum computer, they are more than two. They are building blocks of digital circuits in computing. All the circuitry we have in every single device, computers, mobiles, even here, lights, everything we have zeros and ones. These logic gates are implemented. Logic gates using Boolean logics. Now, what are logic gates important? Why is it important? I asked you the question earlier. Logic gates are used to perform operations on binary. They make decisions in electronics. I said, remember, true or false. You see, they have billions of transistors and they are using zeros and ones as well. It's in CPUs, calculators. Sometimes, I don't know if you've seen it, if we want to buy a memory stick for computers, upgrade it, then it will tell you exactly which kind of gates they use, either NAND gate or AND gate. How do they store data? So they will tell you exactly which one are implemented in those particular chips. Real world light, traffic light controllers, or washing machines. So, for example, we have outside the street lights. When does it turn on? When there's darkness. So they have the two states as well. When the light is there, specific light threshold, don't turn it on. If it goes away, the threshold goes down, then turn it off, turn it on, and in that case, turn it off when there's light, enough light, and so on and so forth. So we're using the binary there as well. Types of logic gates. The first one we call them NOT gate. Next one AND. Other one is OR, NAND, NO, and this is called exclusive OR. We are going to study each one by one, what they are, their symbols, their truth tables, and their real life implementation. The first one we are going to call is called NOT gate. It's called an inverter as well, which means it's going to take only one input. You'll see others, they take more than one. So if you give them one, it's going to turn that into zero. If they give them zero, they're going to turn that into one. So remember, sorry? False, exactly. So it's going to, the property of a NOT gate is it always take one input and give us one output. And it inverts whatever you give, it inverts that one. So basically two of the options, 0 and 1, is going to give it true or false, on and off. It's going to invert that. If input is 0, output is 1, and if our input is 1, output is 0. Okay, the NOT gate outputs the same value as the input. False. It's easy, it's not that difficult. Now, one thing I want you to focus on, very important, Individually, they are easy. But when we come to make a circuit from it, then we will have all different, then that's complicated. So if you are good at individually recognizing the tables, the symbols, then making a big circuit is easy. But if you are struggling here, for sure you will be struggling later. So that's why pay attention to individual ones. Triangle, so the symbol looks like this, and we know the direction as well. Input has to be from this side, output this side. If you're making circuit, if you, let's suppose one of you become electronics engineer, if you put them, invert them in the wrong direction, you either get a wrong value or maybe the whole circuit will blast. So it's very important you put them in the right direction. This means the input goes from this direction and output will be on this direction. So it's not the other way around. It's exactly as you see it. Not is just inverter. It's invert. The not is the name of it. It's the name of this gate. Not is the name of this gate, a not gate. So triangle with the way we write it is triangle with a bubble. That's how we represent it. Arrows indicate direction. So it's going from left to right. If I just switch it, then input will be this side and output will be that side. Yes. Now, this is called a truth table. What does the truth table do? It allows us, it helps us to understand. What does the truth table do? It helps us to understand all the different combinations of inputs and outputs for a specific gate. The smallest truth table we will have is only for NOT gate because it takes only one input and one output. But others, they will be bigger. So I'll show you the tricks as well. There's small tricks to remember. Hopefully you will never forget it because I did it about 10 years ago and I still remember those tricks. So I'll show you some tricks. If you remember those, khalas, inshallah, you won't forget it. Okay, the truth tables show all input output. It helps predict the behavior of the gate. So if you see here, this is going to tell us, for example, if you're using this gate for switching on and off, this is going to tell us that this is going to be the switch is on, the switch is off. So we can detect, we can figure out from the table. I hope this is clear. Now we have the reason it's important. You need to understand the symbol. It can come in exam. The table is going to come in exam, and the same thing with the expression as well. These can come in exam. So you need to know what this is and how do we explain them. So the way we do it is X, which is output, not A. So we say that. So we say that X takes the value of not A. So we assign this value to this one. Remember that. Same in programming. We have the variable on the left hand side and assign the value whatever is on the right hand side of the equation. This is one expression. So we write X is equal to not A. The second alternative we have X is equal to A bar, or it's called vinculum, the top bar, which means whatever the value of A is, invert it and assign it to X. This is what it means, okay? X is equal to A bar, and then this is actually for bar. Whenever you see not the top bar, we will see in other tables as well, or science expressions. That means you get the value inside whatever you have here, whatever the value you have, invert it. And I'll show you example, then that will make it clear for you.
Just, I want to understand something. So the A with the radiculum is the input, right?
Yes.
And then the X is the output.
Yes.
So, for example, 1 with a radiculum and it's equal to 0.
Yes, if it's 0, if A is equal to 0 as input, but the inverter says put 1 there, so this will be changing into 1. So that will be the final one. That will be assigned to X. Okay. That means you wanna, whatever the condition is, you wanna change something. Why do you press the button? Why do we press this button? I press it, the moment it's on, I do something, I invert it. So change it, take it off. So that's why you bring change. That's why we bring change, okay? And we'll see. We gave the example of street light. How will we change how we turn on the lights in the evening? Because we use the same gate. We have a threshold. If it's met, that means change that value to 0. And when it's 0, then change the light. That means the light. Oh, you can implement in many ways. If you want to give the value 0 to light, or you want to give darkness, it depends on that. And then you can change accordingly. It's up to you. When you're making actual circuits, then you can switch it. Whatever value you give, as long as it's clear in the beginning, You want to assign 0 to darkness and 1 to brightness, or vice versa, then you will get the opposite results.
That's cool.
No, it's okay now. Okay. So next one we have a real world. So we have a sensor. For example, here we says A is when it's sunny, so we give them 1. Remember I said in the beginning you can assign, but at the moment we're assigning like this. Output would be light on when A is 0. That's the only way we can do it. So that means A become darkness input. So we get the value output. This is where we use the NOT gate. This is the easiest one. Go to the next one. Okay. Question, Isa. The NOT gate requires 2 inputs. Isa. Yes, true or false? False. Okay. Ahmad. If A is equal to 0, then not A is equal to 1. Is that true or false? True. NOT gates are never used alone. False. A truth table helps explain how gates work. Ali. True. Logic expressions are always written in Python. Ali. Good.